Hey everybody, welcome back to the 128th episode of Taps Patience. That's a cool number because it's a 2 to the power something. I'm AJ with Audacity Micro and Subtract Manufacturing, here with Harrison of Precision Ingenuity. Hi Harrison.
How we doing, AJ?
I'm doing all right. I've been struggling on some parts, but we can talk about that.
Ooh. Big parts, small parts? Parts of unusual size?
Parts of unusual size.
Okay. You branching outside your micro background?
And strongly regretting
it. Fair enough.
We'll get there. How you doing?
You know, I'm exhausted right now. It's been a very busy weekend with a lot going on. Not
From
business related.
Work stuff or family stuff?
Family stuff.
Yeah.
And honestly, I have a lot of different things that have happened between when we last talked and now. Like a lot of different things. Some business related, some family related, some just a little bit of everything. So I can go into it, or if you got anything you want to, do you want me to start, or do you want to start?
Let's alternate. So you start, and then I'll complain about making big parts, and then we'll go back and forth.
Okay. So do you want me to start with business or family, and do you want me to start with what people probably want to hear about, the CMM, or do you want me to put that off towards the end? I'll let you decide.
It's not a Taps and Patience episode if we don't go like 20 minutes about something not related to machining for the first 20 minutes.
Okay. So, I'll do all the family stuff first then. So, some big things that have happened in the family in a very short period of time. My brother is getting married, so he got engaged. I don't know if I mentioned that on the podcast, but my youngest brother is engaged. We just got done doing a birthday for my grandmother today, which was why I'm so exhausted. She turned 90, and
she wore you out.
No, just getting all the stuff done for the event wore me out.
Yeah.
So I baked like 200 cookies for the event and made them from scratch. So I make cookies from scratch. It's fun. And so we did that, and then the weekend before that, we had a birthday for one of my cousin's little girls, and she turned 1. And when everyone was starting to leave, one of the grandparents, her husband's parents, her mom, tripped and fell down the stairs and busted her head open. And we had to call the ambulance. And so far, she's okay. But it was pretty wild there for a little while. And so that was 2 weekends ago. And then this weekend, my brothers, and we've had a bunch of family in this weekend for my grandma's 90th birthday. So been a lot of family this weekend and that whole scare last weekend. So that's kind of all the family stuff that's happened between now and here. And I could go into detail about any of it, but that's not really what the podcast is about. But everyone is safe, and celebrations of different types are happening. So
do I get to talk about my parts now?
Yep, I'm ping-ponging it over to you.
So I took some big parts that I'm deeply regretting, and most people probably wouldn't even call them big parts. The stock is 10 by 17. The parts are a little bit smaller than that. I have a pretty healthy margin on either side, but not a huge amount. And the final part is an inch thick. My material is 1.25 inches thick. And I have been having huge issues with warpage on these. Mm-hmm. And it's probably something that people who make big parts are just familiar with. And just because I make small parts, I'm not used to this amount. Mm-hmm. But if the part is rectangular, think of it as like an 11 by 17 piece of paper. The op one I did in 2 vices on the VF2s at school because they were big and had more horsepower. After spending, 20 minutes of rearranging vices and taking vices off different machines and putting them back on, I found out of all the Kurt vices we have in that school, no 2 of them are the same. So we have like 6 of them, and they're all different. And we had these chick vices, which I absolutely hate. And those ones are the same, and we have like 12 of them, but they could not hold the material. So I ended up getting two Kurt Vices that were pretty close to being the same and cutting step jaws on them to end up with, nice flat parallel surfaces at the same level. And that worked pretty well. And I tried to do one vice, and I sent Harrison a picture, and Harrison yelled at me, and he was probably right.
Yeah,
So I
that's a
put it
bit much
across
for one
two
vice.
vices, and Harrison was like, "All right, be really careful. You don't clamp it too hard, so you don't put a big bow in it." And I was like, "Okay, yeah." And I was pretty gentle. And turns out that was not the direction of bowing that I had to worry about. So
Oh,
I was
really?
clamping it. Yeah, I was clamping it across the short direction, if that makes sense. The direction you would think you would hold it in a vice. But I machined the op one and flipped it over, machined the op two. I did the op two with musical strap clamps and kind
Mm-hmm.
of did the rearranging thing. And I pulled it off of there and measured my final part. And the two ends, dead on nominal. I was like, woohoo. Measured the middle. The middle was 30 thou undersized.
Mm-hmm.
So basically it bananaed up on the ends because when I removed that top hat. And I had not seen that coming at all. I thought
Yeah,
it was going to bow in the direction of the clampage, not the opposite direction.
it all depends on material warpage.
Yeah, so I made another one, and this time I switched to the super glue method because I was tired of musical strap clamps, and I left myself a pretty healthy margin. Actually, and on this one too, I was a lot more careful in op one, where I machined it flat in op one. I released the vice tension, reclamped it, faced off just like 10 thou. I put some marking fluid on the surface and just went down until all that marking fluid was done or was gone. And it's like, okay, well, the top's got to be flat now. Flipped it over. I left myself like 30 thou extra on the back where I, was prepared to, flip it a couple times or whatever. But I faced it off to the thickness where it was 30 thou too thick. And that thing bent itself by a 16th of an inch. It was 60 thou.
Oh, wow.
It was, yeah. And so I didn't have enough margin to clean it up. So I went and bought more material, and I'm working on remaking them now. But it's wild how much that stuff is moving. Or at least to me, it's wild. Maybe it's normal. I don't know. But
It all depends on the quality of the material. I've had some that move just like you're talking. I've had some that don't budge, and it really just depends on what you get from your supplier. I do know that if you get hot rolled over cold rolled, it's less likely to
this
warp.
probably was cold rolled.
So
Yeah.
the the
Should I
the
have
cold
gone to inch and a half thick?
if you're doing cold rolled, probably. If you're doing hot rolled, you might have been fine.
Okay.
But like
Um,
the cold stuff, just banana peels so much.
my other thought was getting it cut out of plate might have helped.
Would have helped, but um, yeah, it's the hot versus cold, especially on big flat parts, makes a huge difference. I've seen if you had a heat treat oven and you could relieve the stresses that was large enough, then you would definitely be fine and anneal it back.
Yep.
So
The with these last two pieces of material, I'm playing the face and flip game. So I'm going to face and flip them down to thickness, and then super glue work holding the side and profile op.
can you machine the bulk of the material and still face and flip? Like, can you rough everything out to like a 16th or so and still face and flip method? Or is there features on it where if you tried to do that, you wouldn't be able to hold on to it for one of the two ops?
I probably could. I mean, the parts it's pretty simple. It kind of looks like well, I mean, it's a rectangle with a really big bevel on one side.
Is that bevel one of the sides you would try to clamp on it the way you're face and flipping?
So right now I'm doing it with mod vices, and I can go in from the sides.
Okay. Okay.
Which the one thing I regret doing was trying to do this on the school VF2s. Even though my machine is smaller travels wise, it's actually been much easier with the Saunders plate and mod vices, to the
Yeah.
point where the extra 24 horsepower of the VF2s, I think, are weren't particularly worth it.
Yeah.
And I'm getting better finishes with my Tormach than I was on the VF2s.
No, nice.
Same tool.
Same feeds and speeds.
No, I probably am slowing it down a little bit for the Tormach, but
Mm.
um, I am definitely running into the power limitations of the Tormach on this part. Um, I was trying to use my face mill, 2-inch face mill,
Mm-hmm.
and like a 1-inch step over and a 20 thou depth of cut. Because I'm running at such a low RPM, I'm not in the power band of the machine, and it
Mm-hmm.
just does not like it. I'm hitting there's like, if you run at, it's like, there's like 3 zones. There's like green, you can run forever, like up to 100% spindle load. Up
Mm-hmm.
Orange is like up to 150% spindle load. You can run that for half an hour. Red is like you can run it for 5 minutes, and then 300% is it just immediately airs out. But I was in the like orange zone, or like the 15-minute zone, whenever that was, and the facing cut took more than 15 minutes, and so it threw a warning and then an alarm and just stopped, which has been a little bit of annoying. It's done that a couple times. So I've been like playing with my speeds and feeds, like with the override knobs, trying to get
Mm-hmm.
it just below like
Yeah.
100% spindle load. So that machine has got more rigidity than it knows what to do with. It doesn't have the power to keep up with it.
Fair
But I guess
enough.
it's the nature of a single phase machine.
Mm-hmm.
So that's the trade off. I did make other parts this week,
That's
but
good.
let's pivot back to you.
Okay. So we'll transition from family to family plus shop a little bit. So we'll get closer to work. So not only was it my grandma's birthday, but it was also my dad's. And so the family from Michigan, some of them flew in, and this probably won't mean as much to the listeners, but it means a lot to me. Family up north, they have a really big operation, like insanely big, and I've gone up there and I have just drooled over all the equipment and stuff that they have up there. Like we're talking, like if you've watched How It's Made and you see like those, machines turning lathe shafts that are like, like 4 foot in diameter, like that kind of stuff. Like just massive, massive machines. Anyways, they came down and looked at our shop, and they were geeking out over my shop like I geek out over their shop. And it was
That's
just cool
cool.
to kind of like show them what we do and kind of talk about stuff. It's going from the big and the massive down to the small and precise, and they were just blown away with what we had accomplished in our short time. And they wanted to send us some work, and I was like, I can't do big stuff. So but if you have anything small, I'll take a look at it. But it was just really fun to kind of trade like shop experiences. And one of the things that they really liked from the tour was like the 3D printing organization. They have like zero
Mm-hmm.
exposure to all that in their trade and industry. And so them like walking through our shop and seeing like the Gridfinity stuff and how everything is organized just like blew their minds away, because their shops are like the big messy shops, but they're doing such massive parts that like there's stuff everywhere.
Yeah.
So it was kind of cool. That was a lot of fun.
I I wish I had family in manufacturing. I've got a lot of my family is in business,
Mm-hmm.
and there kind of seems to be a lot in non for profit or not for profits. Now that I think about it, um, which hey, at times I am too. But like the closest there is my cousin who is at NASA and does like testing stuff. Like he's in wind tunnels, and but that's like the
Mm-hmm.
closest I get to anyone in my family understanding manufacturing at all.
Yeah. So it was a ton of fun to have them walking around and geeking out, and they it was cool to like have some like cross industry
Yeah.
knowledge sharing, because like they do some machining, but the type of machining that they do is none of it's like CNC. It's all like manual work on massive parts. So, so it was a lot of fun. I enjoyed that.
Cross pollination. Cross pollination is always good between industries and
Yeah,
even just different segments of the same industry.
yeah. Like, they were geeking out of like on our organizational stuff. Like, for example, one of the things we did on all of our workstations is we have Allen keys, and we 3D printed.
Mm-hmm.
And I hate the Allen key holders where you have to pull them out of the top. And so we had one of our interns over the summer come up with a design where all of the Allen keys have an open front, and then they have a magnet on the back that
Mm.
holds them and locks them into place. And then they're spaced out far enough where you can grab one without hitting another one. So it takes up more space, but you can just grab something off of it really easily. And it's all because of the multicolor 3D printer. All of it's got really big labels next to each one that makes it really easy to
Oh,
know which
nice.
size you're grabbing. And so
Yeah.
they saw that and they were just like, that is the best thing ever. And it's like, yeah, I mean, it's little stuff like that that just makes it easy where you can just quickly grab and go. And they have like zero concept of lean. So it's like showing a caveman fire for the first time. There's another way. And so it was a lot of fun. So, but so we did that. Weston finished up all of his training for the CMM this last week. And so we were
Cool.
able to write our first couple programs on the CMM and start using it on some of the medical parts. And how much did I talk about the medical parts we did? Have I have I mentioned
I
very much
remember
on the
they had a feature on them that you couldn't inspect with the tools you had.
correct? Okay.
And you shipped some that were like
Out,
right on the edge or something.
they were out of spec, so there was a 2 tolerance window on the parts, and they were shifted by about 5 or no, yeah, 2/10 tolerance on the part, and they were shifted by about 5 to 7 tenths undersize.
Okay.
And we were using the Haas digital bore gauges. And so we did two things to combat it. One, we bought a massive CMM. No, and then the other thing we did was we bought some um, precision ground gauge pins specifically for that feature. And
Hmm.
so Weston was taking the class and I was running some of those medical parts because we were going to send another small batch to them to get validated on their CMM. Our CMM wasn't quite running, or Weston wasn't trained up enough on it to write a program for it when I was running those parts. But we had the gauge pins as a backup, and so I was able to use those gauge pins to dial in the tolerance. And then right before we shipped the parts, Weston had just enough training to write a program to compare the CMM to the gauge pins. And we were able to validate that our gauge pin method, because we only had like a 2 tolerance window, our gauge pin go no go was actually showing us good numbers. And so then we shipped them out and we overnighted the parts, and then we had them rush inspect them on their machine on Friday, so that this week we can start running production on those parts and we can validate that our gauge pins and our CMM are matching what their CMM is getting. And they ended up passing inspection. It was actually funny because one of the people ended up calling Weston and they said 9 out of 10 parts passed, but they were super excited about it. And then they forwarded us the CMM report, and it was actually 10 out of 10 passed. I think one of them was right on the minimum, but it was still in spec.
Okay.
And so they are just ecstatic from at least what the little bit that Weston's talked to him on the phone that they've had. I guess 9 out of 10 to them is considered awesome, and we're looking at it like, no, we need to be 10 out of 10. I don't want to ship you
Yeah.
anything that doesn't pass. And so we're going to try to set the bar higher than them. But I think they've had such poor luck with these parts and other shops that like a 90% success rate is still considered better than average for them. Which on a feature like that, I understand because it's really it almost needs to be ground in. And they've had people that have machined that part soft and then heat treated it and then tried to rejig it up to take it to final dimension. And they've had people that have done it hard like we have, all and machined it all the way through. And doing it all the way through like we have, they've had the best luck with. But they still have rejection. And I think they do 100% inspection on anything that they assemble just because of how critical it is.
What are
So
you going to do with the CMM? Are you doing 100% or?
I'm going to try to do 100% on all critical features. That's my goal. Is to write a program that every
Okay.
single part that comes off has to go through and has to get checked so that we're only shipping them good parts. But it's nice to know that we can also validate at the machine if the CMM is busy with the gauge pins, the go no goes. It doesn't give us an exact measurement, but you can kind of feel when it starts to tighten up a little bit and know that you need to bump it up by a tenth. So
Yeah. How are you going to handle the flow from machine to CMM to make sure there's not like a batch of parts that are bad that just haven't been measured yet?
we're still gonna have to play with all of that. That hasn't we haven't got all that figured out. I don't know if we're gonna do it every 10 or what, or when things start to get tight or loose. It's we're gonna have to make a process for that. And we don't know what that looks like yet. We're still very early in figuring out the best flow in the shop. We've only run at this point 30 of these parts, 40 of these parts. And we've scrapped a bunch just because trying to hit dimensions. So we're still in the getting everything figured out. I will say we did switch to a Frasia end mill for the hard milling side, and my end mills only lasted me six parts last time before they would explode, and I went through 32 parts or 31 parts with one end mill without it having any issues. So,
Way to go,
and
Frasier.
that was their e-cut line, and I had a really nice long conversation with one of their techs as I was running it and getting it set up. And they said, if we want, they have another line that's even better for specifically for hard milling. Um, if we want to switch to that, and it depends on how many of these parts we run and what kind of tool life I see, if that makes sense. But we might try one of those next.
Yeah,
So,
have them send you a sample.
um, but I'm pretty happy with what we got out of that one because it was what would that be 6 to 30? That's a 5 times increase in tool life, and
What
it
is
was
the cycle?
still good.
Oh, sorry. What's the cycle time on these parts?
On the mill or on the lathe, op one is I want to say 4-ish minutes. Op two is or no, op one is about 5. Op two is about 3 on the lathe. So you got 1 and 2 on the lathe, and then you got 3 on the mill. And on the mill, it's about a 5-6 minute cycle time.
Okay. Are you single piece flowing these or batch working?
We have to batch work because of the lathe. Because
Because you don't.
we don't have a dual
Yeah.
spindle.
Okay. Okay.
So we bar pull all of the op ones, and the op one is the one that has the most critical feature on it of that ID bore. And so the goal is while it's bar pulling, we can be taking them off and running it over to the CMM and checking it while it's bar pulling.
Do you know
We
what
just
the CMM cycle time is?
It's really quick. It's less than a minute. It's super quick.
So you could do 100%.
Yeah, we could if we wanted. You'd just be doing a lot of running back and forth, which I don't want to do because it's literally opposite ends of the shop. We did not design the CMM to have parts run in between it and then go back to the machine. Like that's not how we laid out the shop. This is where a shop floor model would have been better, something small that we could do for these parts. But right now, we've got a one size fits all solution to get our toes into the CMM world. But
Yeah.
if this were to become a high production job, there's other machines out there that can be on the shop floor that can be checking them as an in process check. And I don't know if we'll have to go to that extent. I don't want to go to that extent. If we can validate a good enough process where I can check 1 out of 10 and know that if I check this one that they're good all the way back, at least for in process, and then do 100% after the fact, just to know I'm not getting way off. That's what I would ideally like to do, because the go no go, I can at least check that right at the machine and get a pretty good feel for how it's doing.
Yeah. Yeah, I would definitely use that go no go check 100% of the time.
Yeah,
And then you can monitor the sizes like over time on the CMM.
and I can
Um,
use the Haas gauge once I have a
mhm.
good part. Like I can zero it out and use
Oh yeah.
the. It still works. I just can't go off of its value 100%. And I don't know if that's a problem with the ring gauge. I don't know if that's a problem with specifically how, if the ring gauge is really small or really big, and I don't remember how big the ring gauge is compared to the part, but if it drifts from that known surface to that size, and if I can find a ring gauge that's closer to it that I can zero to it, because maybe that's the key that I need to do, is I need to get I need to get a ring gauge that is exactly the diameter I'm trying to hit, and then zero that tool to that ring gauge, and then it'll be repeatable and tell me where I'm at.
Or if you just, wait until you find a part that CMM's to dead nominal,
Yeah,
like
and then
use
zero
that
it
one
out
as
on that.
your,
Yeah,
yeah. But yeah, I would definitely do the go no goes on 100% of parts if you can, and then have a sampling plan for the CMM.
yeah. Because I between the go no go as like my hard stop, I know something's like, I've had parts that just barely fit in and were snug, and those are like borderline if not undersized, and then I've had parts that the go just barely starts to slip in, or the no go barely starts to slip in, and those are out of spec. So like you can kind of tell between both of those, it gets you pretty good, pretty close.
It does sound like a skilled check, which means your employees might have a little bit harder time replicating that.
Definitely not going to put the employees on this job until we have a good, known, repeatable, bulletproof process. Like the point of having the employees is that me and Weston are going to figure out a process, and then we're going to hand it off to the employees so that they can duplicate and repeat it. That's the goal, at least. And I have started in other areas of the shop creating document sheets and process sheets
Oh,
for a
good.
couple different things. For example, passivation. I created like a 3-page document on everything about passivation, on how I've learned it, and I handed it to my employee, and he was able to read through it and do it without me teaching him. He just read the document and went and did it. And so
Nice.
that's definitely what I want to start doing more of. And I don't know if that, I'd also like to find a way to potentially do it where if he's got a question, maybe the shop wiki or QR codes to like a video, like how Pearson does it. I don't know what it's going to look like, but I want to start doing more of those documentation process stuff so that if there's any questions, they can kind of self figure it out before they come and talk to us.
For school, I've been doing that whole Kanbanization of my teaching. I think we've talked
Mm-hmm.
about that. The way I have been doing that is I made a standard format. It's in Markdown, but it can be in any format you want it to be, with like, the different sections, the different headings, the same structure, whatever. And I take that and I give that to ChatGPT, and I give ChatGPT my just kind of word vomit notes that I've been using,
Mm-hmm.
and it takes my word vomit notes and makes them into a nicely structured, like standardized card template.
Yeah.
And doing something like that might save you a lot of time, where you can even just like voice recorder, or like using your phone's text to speech app or speech to text app,
Yeah.
just like word vomit out everything that you can think of and have a standardized format and be like, here, chat GPT, do this.
Yeah.
Because I made
So,
a bunch of cards, and it's not like, it hasn't taken me that long for the amount of cards that I've made.
yep. So that's kind of an update on both the CMM and the medical stuff. It's looking really, really positive, and using the CMM has been phenomenal so far. It's definitely, from a programming perspective and like setting stuff up, it's not very user friendly. Like the fact that it took a week for Weston to do all the training online, and he still is kind of struggling with trying to get everything, like he can do it, but it's not a fast process and it's not an intuitive process. And specifically how they did that class, like he left a lot of feedback on like there's a way you guys need to structure this class, because they like it's not in order. And it's like, I'll give you an example. We could have potentially used the CMM a whole lot sooner and could have tried to start writing some of our own programs a lot sooner, but they skipped over one step, which was when you import the model, if the model's origin does not match how it looks in the CMM software, like if it's not in the wrong orientation for how you want to probe it, there is a transform function to rotate that coordinate system, and they didn't talk about that until like the third or fourth day. And the
Yeah.
only reason we found out about it earlier is because a salesman who sold us the machine came by, and we're like, "Hey, we're just trying to like measure this bore. Can you like talk us through a few things?" Like he's taking the class, but it'd be nice to have someone standing there and just kind of show us. And that was one of the very first things he did. And Weston was like, that was the last piece of the puzzle I needed to where I could actually start writing some programs and start practicing what I was doing in the class out of the class with our machine. It was like that's like the very first thing, because all the demo models that they have are all in the proper orientation in the
Yeah.
class. And so there's like it just never comes up. And so
I I wish you had said something. The guys on Incremental had talked about this. And what they did is, this must have been Devin. From what I understand from this podcast, that he briefly mentioned it like a week ago, is they built a Fusion template that they use to like design their CMM work holding.
mhm,
And the Fusion template has everything at the right orientation and the right um, like the origin set to the
origin.
right place for their machine. And so they just
Mhm.
drag their part into their template and then export it from there. And I think they can export both the work holding and the model, and they come in the right orientation in their CMM software.
That's smart.
And I know he 3D prints the work holding.
Yeah, which is going to be the next thing I'm going to be working on, because they gave us a kit, like a starter kit for work holding, and I've been using that, but it's very janky, and for these tiny parts, it doesn't do very well. So
You should talk to Devin and like just pick his brain about how he does it,
yeah,
because it sounds like he has a pretty good system.
yeah, might have to do that. But
I I really wish Fusion would just tackle CMMing. It would make life so much easier because all CMM software is awful.
yeah, yeah. Well, yeah, it's a you have to think about it differently to like do the proper GD&T stuff. Um, and like it's not just as simple as probe this, get this value. It's a lot more complicated than that. And so I understand the need for some of the complication, but like it's like going from SolidWorks to like Pro Engineer, and it's just like not user friendly at all.
Yeah.
One thing that is kind of cool though is that the people that get really good at it, when you write a program, it's literally a coded file right beside you. So the guys that are really good will actually like write the program like they're writing a like they'll actually write the program out like G code,
In
except like
text form.
in text form. And so like, or they'll bring in a feature and then they'll go to the code view and they'll start modifying all the settings for that particular feature. And it's like, oh, that's really cool if you've been doing it for 10 years.
See,
But like,
yeah,
I
I feel
don't
like
even
this is not a sign of a well designed product.
know.
This would be like you're making toolpaths in Fusion, and oh, I can't get Fusion to do what I want, so I'm just gonna go edit the G code. Like, can you
Yeah,
imagine if Fusion had a G code editor like side by side with your toolpath?
I know.
No.
I know. It is kind of cool from like the only thing that makes it cool is how complicated everything else is. It actually makes that look usable. Because like
Can
just
you
the
have Chat
windows,
GPT write your CMM program?
I don't know, maybe that
Mm.
would be pretty wild. I don't know. I don't even know how you would do that because like you have to go click on stuff in the actual model for it to connect.
Oh, okay.
So it's not straight up code because
Yeah.
like you got to go click on features and tell it this is the circle, but you can like write the code to like how many points you're doing it, how fast you're touching it, the spacing, the depth, and all that other stuff. So, but yeah, I mean, it's it's both cool and it's cool to see someone who's been doing it for 10 years like to be able to go in there and just like master program right on the fly, but it's also not very user friendly and just shows how bad everything else is if that's what everyone gravitates towards.
Yeah.
So anyways, a lot to learn there. I've noticed that our the um split AC unit that we have in the wall, it does like it keeps the window, but it's like hitting both the extremes,
Mhm.
the high and the low. So it's still in the bounds of safe, but just barely. Um, so we'll have to watch that and see how that changes with time and different times of the year. So, but yeah, that's kind of the CMM and the medical part. I'll ping it back to you.
So I did make some tiny parts this week.
Hmm.
They, for the most part, they actually went very smoothly and easily. Those ended up being a pretty good job for me. They were they were, I think, zero point 0.3 inches long, 300 thou long, and a little under 100 thou in diameter. I think they were probably 2.5 millimeters, 98 thou in
Hmm.
diameter. They kind of looked like they were like the size of a really, really big grain of rice, or like a grain of rice scaled up 1.5 times, maybe. We get you the
Hmm.
general ballpark. But they had a 1/16 inch hole that went all the way through them. That ended up not being a problem basically at all. But they had like a little flange in the middle of them that had, or actually no, there was two separate diameters. So there was a skinnier diameter, there was a larger diameter. The skinnier diameter at the top of that had flanges. It had two little flanges that needed to be undercut. And then there was like a smaller diameter that went down, and then there was a step where it transitioned to the bigger diameter. Um, on that step, there were two holes that were 10 thou in diameter and 100 thou deep. And they were at the bottom of a feature that was like 150 thou. So basically, I had to drill. Well, I needed a drill that was 10 thou in diameter and a quarter inch long. And to make matters worse, the holes were right up against the central cylinder. There was like a little
Hmm.
cutout on the top flange for them, so they could be basically tangent with that central cylinder. And I broke a lot of drills. I also had a hard time finding drills that would just let me do the feature at all. I originally found some just like traditional drills on McMaster. And so I ordered 12 of those, only for them to get here and me to realize the smallest collet I have is a 1/16 inch collet. And the 1/16 inch collet does not clamp down to 10 thou.
Oh my! You didn't get like the
So
PCB drills, or those aren't long enough.
so the ones I had and the ones on McMaster were not long enough.
Mm.
What I ended up doing is, fortunately, this part was a plus or minus 5 thou part all over. And so I stepped up to, it was a metric size, but it was a little bit bigger. Um, let's see, it was 0.35 millimeter. Yeah, I stepped up to a 0.35 millimeter, and I found a longer reach one. And I still broke like six of those.
Hmm.
Um, but I was able to get the parts done.
When you broke one, did it scrap the part, or were you able to?
Yeah.
Yeah.
Now the parts, like, they had a grand total of like 12 minutes of cycle time between op one and op two,
Hmm.
and the materials on them were like
Nothing.
25 cents each. So I scrapped a lot of parts I made a lot of these things, and I think I probably I made as much scrap as I shipped. So I probably scrapped 10 and shipped 10. But yeah, the I think the biggest problem I was having with those drills, besides them just being really long and spindly,
Hmm.
because that's like a 25 times D stick out that I needed, is I couldn't spot drill for them
Yeah.
because they were tangent with that sidewall. My spot drill would have to be the same diameter as the drill,
Yeah.
and that gave me issues. So I did a lot of playing the speeds and feeds. I also used some of my tolerance range to expand out that step by like 2 thou because they were so close. Like the part was very tight. It was a very compact little part, and the drill was like expanding out the sidewall a little bit,
Hmm.
and so I had to give myself an extra couple thou to give it some more meat.
Were you machining those feature? Were you machining everything down and then had like thin walls that the drills were then machining? Like with your order of operations, if you started with a block of material, was the drilling towards the end or towards the beginning?
Initially, it was towards the end. I did eventually change it where I roughed, drilled, finished, just to make sure that there was no signs of the drill on the outside of the part.
Okay. Because I
But I was
had a
also
part.
afraid of distorting the part or distorting the holes. But
Yeah. I had a part that was in stainless that it was tapped. It was probably a 2.5 inch long part, and it had an M6 tap that went almost the full length of the part. And then if you think of the tap going through, the tap was on like an island where, if you imagine a block and then there's a line raised up in the center,
mhm.
that center line or that center rectangle was the drilled and tapped section, and the walls on either side of it were like 20 thou from the major diameter of the tap. And so I kept blowing out taps and breaking them on that part when I was doing it, because the stainless was so thin that it would heat up and work harden and break the tap.
Yeah,
And so I had to drill and tap that feature while the part was thick and had the mass to be able to dissipate that heat, and then come back and machine everything around it afterwards. and
that
and
makes
then it came
sense.
out perfect. So like with tiny
Yeah.
drills like that, if they're close to a wall and it can build up heat, it can really do some funky things. And so you almost want to make sure you have the most amount of material around your features while you're doing that, and then come back and machine everything else.
I had an
So,
oopsie on another part this week.
oh, what's that?
This was in the pre machining stage. So the part looked very much like you know it, Audacity Micro bread and butter. It was a small, skinny cylinder, or no, excuse me, not skinny. It was a flat, like it was fairly wide and flat in aspect ratio. I don't remember the exact size, but it was no more than a 16th inch thick, and I don't know, maybe double that in diameter, something like that.
Mm-hmm.
I misread the drawing, and there was a flatness and perpendicularity call out of a
Mm-hmm.
thou. So I thought it was, in fact, a flatness and perpendicularity call out of a tenth. And
Oh,
I went to start working on the parts, and I went, oh, I can't measure this. And so
yeah.
I had to go back to the customer and be like, I can't measure this. I can measure to a thou, sure, but I just don't have a way of measuring the perpendicularity on a wall that's a 16th of an inch to a tenth.
Mm-hmm.
So, do you just want me to mark it as best effort? Do you want the parts back? And I haven't gotten an answer yet, but I had to be
Mm.
like, sorry, oops.
Yeah. Yeah. Gotcha. Yeah.
Those decimal points, they're important.
They'll get you when you're not paying attention. We did go and tour another shop, and I was able to take my employee with us. So me, Weston, and our employee took a little field trip to visit another shop. And that was pretty fun to kind of expose him because he's not a machinist and he's been a programmer, so he doesn't have very much
Mm-hmm.
experience in shops other than our own. And he got to go see the traditional shop that's like a mess and dimly lit, and toolboxes are not organized, and
Yeah.
parts are everywhere, and there's carts everywhere that are just covered in broken tooling or like half taken apart machines and all this fun stuff. And we got back and he was like, you guys are doing like this is so much cleaner than those other shops. So I was like, yeah, let's keep it that way. Let's not turn into one of those shops if we can help it. And so but it was fun. We went and looked at a Lynx lathe, a Doosan lathe.
Ah, cool.
So uh and it was they were doing some pretty cool parts on them. They were running some parts that had some, like a shaft that's like 6 to 8 inches long and maybe a half inch in diameter that had like a 1 to 2 thou OD dimension on the whole length of the part. So basically Swiss type work that they were doing on the links
Cool.
with the dual spindle setup. And they had some tips and they had some tricks and stuff they were doing on it, but it was kind of cool to see. And it also had a spline on it that they were milling into it. Very similar part to one of the Titan demos on the Swiss Tornos that they had at their demo day. Very actually, now that I think about it, almost identical looking to that type of part.
I mean, good demo parts should look like real world parts. So
Yeah, so it's kind of cool.
I
So
did
that gave
actually
me.
make.
Go ahead,
I was just gonna tangent.
go for it.
Oh, I was gonna say I made one other part this week,
What was
and
that?
that was a YouTube video that just went up. You probably didn't have a chance to see that one. It
Oh,
went up earlier today.
the brass part with the
Oh,
chair.
yeah, you said you had something. Yeah, it looks like a recliner. That was not
Yeah.
intentional, but it very much looks like a big comfy chair.
Okay.
Um,
So you had your cube that you were,
yes,
or you, and you had your Aroa chuck, and you didn't have a good way to find center.
correct.
So the best way to find center that I have found, especially when dialing in like the I did this specifically when I was dialing in
MRCP.
the fourth axis on the Doosan.
Okay.
So you take a cut on the side of the part, say on the left side of the part, you rotate the part 180 degrees and you take another cut on the left side. Then you rotate it 90 degrees and you take a cut on the right side, rotate it 180, take another cut on the right side. Make sure it's the same cut, the same material removal rate. Then you measure across the flats and that'll give you your left, right. One of those, you're trying to go for a square. One of those sides is going to be bigger, one of those sides is going to be smaller.
Mm-hmm.
So that'll get you one dimension. And then you do the same thing with Z. You shave across the top, flip it 180, shave across the top, and you want all of those measurements and all those different orientations to all line up. And that's how you can check it without having a precision block like you were looking for to probe it in. It takes a little bit more time, but you can get really freaking accurate, especially if you can use a micrometer to measure all of those different dimensions. It'll get you bang on the center line of that Aroa palette.
Yeah, I got pretty close. I think I got within about a thou with my probe flip probe average method. Um, so for what I was doing, it was more than good enough.
Mm-hmm.
Um, and that little thing I was making, I never said it in the video, but that is a proof of concept on a way that a low cost little vise could be made, where I'm using basically you can use a soft material for the body, and then two sets of three dowel pins to act as rails. And dowel pins are basically just a you know something that's cheap and precise and hard that you can buy off the shelf. So to make some like little dovetail vices or something like that. That was the theory.
Have you tested it, or is it still theory at this point?
Nope, I have half of an assembly. So I had like an hour that day and I knocked out that one part in an hour and then I had to go do other stuff. So at the moment, I had to remove all of the 0 point stuff off of my table to do the big parts, which is annoying because now I got to indicate all that stuff back in to make sure it's square and parallel. But
Gotcha.
I'll probably use this opportunity to do some rearranging on my table that I've been meaning to do anyway. Because I had this problem where I put my tool setter right next to my vise and
Mm-hmm.
it blocked the signal if you weren't, if you were at the far extreme of your X travel. So if you ever did like a tool breakage detection and just the table was in the wrong place, it would
Mm.
fail. So I was like getting around that by doing some manual G code to like a pass through NC in Fusion to like move
Mm-hmm.
it to the place where it can see the sensor. But if I just move the vise a little bit relative to the tool setter, I might swap which side my Aroa system's on. I'm unsure about that yet, but or just stick that thing on a riser while I already have everything torn down, and that'll fix all those issues.
Good deal.
But that little brass part I made using my not a 5-axis method, and it worked super well. The only thing that went wrong, and I didn't explain this in the video, which I should have, was the not a 5-axis method works with the 0 point based off the center of rotation,
Mm-hmm.
and it assumes that CAD matches reality. But in reality, my part was, I think, 30 thou off, or excuse me, my stock was like 30 thou off center. And I had
Mm-hmm.
designed that part to be as big as I could get it to fit inside that material. And, I didn't have 30 thou of margin on each side.
Yeah.
So 3 out of 5 sides got, or no, 5 out of 6 sides got machined very nicely. And that last side is a raw extruded brass texture.
That's
But
that.
I
That is the
parted
one
it
problem
off and
with that.
everything.
Yeah, I saw that. That was cool.
So it worked. It worked really well. I was very happy with that whole process, except there was a couple little programming things little mistakes that I made. They were actually a result of me using Toolpath.
Oh, really?
I did very little programming on that part. I programmed the parting operation and I rearranged operations a little bit. And if you watch back that video, there's actually a part where I'm like, oh, I didn't do a finishing pass on these walls. And that was because the way Toolpath programmed it like the operations were in order that I didn't want it to do. So I rearranged the order of operations, and then it was doing the finishing paths too soon, and so I deleted it from the first operation that used to be the second operation, and then I never added it back into the second operation.
Gotcha.
And then also because of that, I did some like drilling and countersinking on the first operation. Or I guess it was a chamfer, not a countersink. But when Toolpath programmed it, that was going to be in the second op. And so it wasn't accounting for there being the extra 20 thou of material there or whatever. But I didn't think about that when I switched the order. And so it was brass, so it was fine. But like my chamfer tool just kind of plunged through a bunch of material didn't expect. But other than the parting operation and a little bit of reordering, that was all Toolpath. So I've been doing a ton of Toolpath programming recently. We had like final project day with a group of 12 students the other
Mm-hmm.
day at school. And I think they like, between the 12 students, they had like 9 final projects. A couple of them kind of shared the same project, but I programmed all of those in Toolpath. And I've been building like my templates instead of like having templates and trying to shove Toolpath into that. I've been building my templates to serve Toolpath because I want
Mm-hmm.
to use that more going forwards. And it's been working really
Nice.
well. So my tool library is pretty much dialed. I have a slight issue with my tool library where we used a spreadsheet to build it. Jacob and I worked on this, and we made a mistake with the math where we were confused by the names that Fusion used for the columns,
Mm-hmm.
and instead of like the stick out of the tool being the length of, or what was it? It was supposed to be, well, flute length is supposed to be what sticks out. Like flute length plus shoulder length is the stick out of the tool, right? We did the math wrong where basically that much is inside the collet, and then what should be the shank that's left over is sticking out. So if you had a tool with like a 2-inch overall length and like a half-inch flute length, normally that would have an inch and a half inside the collet and then a half-inch hanging out. Well, we have all of our tools set up so it has an inch and a half hanging out and then a half-inch in the collet in my Fusion library. So all of my tools look really dumb right now, and I have to tweak that. And I just need to go back and like re-export the tools as a CSV and then like flip that math around. Because some of my tools look really silly right now. but having that tool library nailed down with the pre-tool speeds and feeds in there, and I just finished setting up a new tool cabinet that matches the tool path numbering scheme that I use.
Mm-hmm.
And I'm working on getting Kanban cards for those built up. So like my tool library and my workflow for programming is really dialed right now, and I'm really happy with that. So good job, Toolpath. Now
Nice.
I just need to get my fixtures as equally dialed, and then a robot to swap them in and out, and then we're automated.
Nice. Yeah, I still like automation is going to happen. It's not if, it's when.
Yeah. If anyone would like to trade a robot for an office mill, I have a deal for you.
Nice. Trying to think what else we got going on. We got the battleship parts again. So time to put the Doosan through another trial. Hopefully it doesn't.
Oh, is this what did the spindle last time?
Yeah. This is no, it didn't actually deal it in. Remember that it actually survived the last one. It did.
Okay,
but it's going to be the same job.
Louder.
No, it ended up being like there was one RPM where there's a slight harmonic, but it's not any louder. So,
speaking of those battleship parts and your Doosan, actually nothing to do with the battleship parts, all to do with your Doosan. We do have a Patreon question about Doosan.
Okay.
Which I have just butchered the intro to. But not to beat this with a dead horse, but we have new Patreons. Those new Patreons include a dead horse. So all of our Patreons get access to our weekly Q&A, which we'll do here in a second. All paid Patreons get early access to our episodes. Jacob's been doing a really good job of getting the episodes out like next day, if not sooner. So that's been really cool. And Patrons get access to our Discord, which you can both use to ask questions or do that on Patreon. And I don't know, keep in contact. It's turned into a really good community. The Discord has been very fun. Our Patrons include, but are not limited to, a dead horse, Daniel R., James at Moultrie Made, Ryan at Strato Manufacturing, Austin W., Kyle at Kursk Machine, Devin at Sinister Machine Works, James N., Ben at Prickly Pear Prototypes, which, Ben, we still need to get you on the podcast, Cam S., Shep at Alderson Prototyping, Jacob at Zana Precision, Jason S., Joshua H., Christian Z., Freaky Climber, Prescott at 1Z2Z Systems, Trey V, Guy L, Alexander B, Scott Designed Everything, Jamie at JSpec Engineering. Ooh, and I think I might actually put the anchor on my machine now, maybe instead of my 6-inch vise, but we'll get there. Chris Zyke at Zyke Precision, EJ at Nocturnal Welding, Chris at Thought Bomb Design, and as ever, Jake Brownson. And actually, speaking of Mr. Chris at Thought Bomb Design, he published a video earlier this week or last week where he molded a carbon fiber caliper case. And it was very cool.
Was that on YouTube or Instagram?
Yeah, that was a YouTube video. So he had like a 10-minute YouTube video where he 3D printed a mold and then like filled it with carbon fiber and resin and pressed it down and made a really slick caliper case for his calipers. My only complaint, Chris, is you didn't make a carbon fiber lid, but it was pretty cool. And it makes me definitely want to do some carbon fiber now.
Okay.
I was thinking about putting the anchor point on my table as a way of holding trays of material. And in this case, it would be like pallets. So I could like put a holding pallet on the anchor point, and then use a spindle gripper to lift up the pallets and stick them into the Aroa system. Or I could get one of the whatchamajiggers, what they're called, the like pneumatic vice actuators from Lights Out Manufacturing, and put
Mm-hmm.
that on my 6-inch vice, and then I could use the anchor point to hold trays of material. Um, I think it's Austere Manufacturing, Uriel. He does that with laying 0 points, I believe, and it sounds like a good idea and a good use for the anchor point.
Mm-hmm.
Um, I was also thinking about making a big super glue palette out of the parts that I've been scrapping. I could just like put them on there and then face them flat, and that might be a good use for the anchor point because it's bigger than my Aroa system. So anyway, Q&A. Cameron S. For Harrison, we've been looking to upgrade our very... Oh, for Harrison, colon. We have been looking to upgrade our very old Boxway CNC mill. Do you think the Doosan is notably more rigid than the Haas? If yes, is it from the dual contact or the casting?
So I would highly recommend going for the D&M Doosan mill if you're looking for rigidity. If the SVM is any more rigid than the Haas machine, I would say it probably comes down more to the dual contact than the actual casting itself. I'm sure there's a little bit from both. And actually, I would say the Doosan vibrates more than the Haas in the same type of cut. And so the Haas actually has more dampening. And I don't know if that dampening is because it is less rigid or because it has more mass or something else. I don't know if that's a better or a worse sign. I just know that the Doosan is more likely to vibrate and have the sheet metal and everything start rattling. And if I put the same cutting conditions on the Haas, it sounds fine and looks fine. So if there is any more rigidity in it, I think it's in the dual contact, but I think the rest of the machine is built for speed, not rigidity. And if you want more rigidity, go to the D&M. And obviously, from a spindle perspective, it should be way stronger.
If you could
So
swap out your SVM for the equivalent of Haas for just like no cost, poof, it's there, would you?
if it depends on when you asked me, I would say
How
the
about
only
after
reason
the third spindle?
the only reason that I'm more hesitant to it is because there's some jobs coming up that are aluminum high volume that I'm looking at putting on that machine, and I think that is what that machine is made for. And so
Great
if I
machine for
get
aluminum.
it's a great machine for aluminum. So I'm looking at the gimbal automation system and doing small 1-inch aluminum parts in high volume, and I think that machine will absolutely kill it in that scenario. And so I will be playing more to that machine's strengths. And so that's the only reason that I would probably hesitate from going over to the Haas machine. Although I will say I did have an interesting conversation with the Haas tech whenever they were visiting. They just stopped by one of the Haas application engineers stopped by the shop for a little while just to say hi. I think he brought someone by, and I don't know if it was they were just in the area. I don't remember what exactly it was, but he just came by to say hi. It wasn't scheduled, and we got talking about the Haas machines and the Doosan, and he said they're working on increasing the accelerations on the Haas line across the board to be closer to like the Doosans or like Fanic style machines where they have faster accelerations. And it sounds like that's been a limitation of the CNC controller used by the Haas machines. And they're looking at upgrading the chipset in there, which will just immediately give a
Interesting.
speed increase to all the machines or acceleration increase. At least that's kind of how he worded it.
So,
I wasn't sure if that passed the stiff test, but that's kind of what he said.
so if someone offered to swap the Doosan for like a Speedio S700, like poof, the Doosan's gone, poof, there's an S700.
It all depends
Maybe
on the work that
exclude any like mental math about price difference, but
yeah.
because I actually don't know how the prices compare. I imagine Speedio's cheaper.
I don't know. We got that machine. We got a pretty good deal on that machine. All in with a fourth axis. It was pretty cheap and a conveyor. We got like a 20 to 30% discount off the price of the machine. They were running a promo, and so it really was not that expensive for what they normally cost. Um, but I don't know. Everyone that I talk to says I'm an idiot and that I should have gotten rid of the machine. But I mean, I'm gonna use it. I don't I don't. It's caused me to go outside of my machining comfort zone and learn another machine other than Haas. And as much as it's easy to look at it and go, you've blown up 3 spindles in it, it's a shitty machine, which is how probably most people would look at it. It's on me as an operator to use the machine in the right parameters, even if I thought it could handle more. It's still like, if you buy a machine and you use it outside of how it's designed, then it's on you if there's problems. By the same token, it's not how it was advertised to me. So it's not 100% I'm using a hammer, I'm using a screwdriver as a hammer and not getting the results I wanted. So like it's not 100% on me, but at the same time, if you use the machine in the right way, I still think it's a really good machine. I just don't think it's I don't think it's a VF4 just stick it in there and expect it to take everything in stride machine. Like I think the VF4, it can take a beating and is just it's closer to the D&M style machine in use case, and the SVM is just a lighter duty, can't take the the loads as well as the Haas machine. So
So
I
don't
don't
buy an
know.
SVM.
You don't buy, like, unless you're going for like the D&M has closer accelerations to the VF line. And I do think the D&M is going to be a better built machine than the VF line. I think that I don't know because I have no experience with one, but that's just what my gut tells me. And so I would go SVM, VF, D&M. But that SVM, Haas doesn't have anything to compete with it in terms of its speed and accelerations. So like I can run the same program on both machines and I can get anywhere from a 10 to 30% reduction in cycle time on the SVM over my VF.
They
Just
have
in
the
pure
DT and DM line,
huh?
and now they're new. They have the DT and the DM, and now the new DC line.
They do, but those I think like I don't think those are going to be anywhere near as rigid as the SVM. I don't think. I don't know, but I don't think.
It just feels like if your argument is it's for small aluminum parts, then you buy a Speedio. If your argument's that it's rigid and does big stuff,
It's
then you buy a D&M. And
it's
it's
like
just
it's
like
in
doesn't have its own
it's
place.
like in between those two is the weird thing. Like I think it's less than a VF, but I think it's more than a Speedio. And I don't know how that falls into like someone's workflow. So like I said, I think it's more of a targeted machine, and I don't know what that target market is for. Like I'm sure there's someone out there, if you're doing large aluminum parts on like and you need to use that full 50-inch table and larger cutters with more torque than what you can get out of a
Long
30
tool
tapered
length.
machine. Yeah, long tool length. Like I think that is what that machine will just absolutely kill in. Like if you got big aluminum parts and you have long projection tooling, that machine is gonna just kick ass in that setting. But like it doesn't have to be small aluminum parts. It's just that most of my parts are smaller and aluminum. So for me, it might not make the most sense. But small aluminum parts are the ones that are the best fit of the parts that I'm getting that I could stick on that machine.
Well, and it would
So
be nice with a whatchamajigger, a gimbal
gimbal,
automation system setup,
yeah,
because you can fit so many more parts on there than you could on like a like a Speedio.
Yeah,
I don't
yeah.
know how big is the table on an S700 compare.
Time to do
Um,
Googling on the podcast.
yep. What if you were offered like an R450? Those are the dual table, like
Yeah,
spinny around him ones.
I want one of those really bad.
27 inches in X, 28 inches in X,
Is
15
that
in
the
Y.
table or
What's
the?
your Doosan?
Oh, is that the
Travels.
tape travels? The Doosan is 50 by 20.
So yeah, you can get a lot more parts on the table of the Doosan.
Yeah, yeah. And I don't know if the dual table, if you're just doing gimbal um, automation stuff, that dual table, I don't know if it's going to gain you anything. It's not going to
The
gain
dual
you any.
table doesn't make sense with gimbal.
Yeah.
That
So
only
if you
makes
have a
sense
robot
with
on the
like part
outside,
loading.
then it makes
Yeah.
sense with the robot because you can be loading and unloading on one end while it's cutting on the other. And I think a dual table with a robot is going to take up more space than the Doosan with gimbal.
Yeah. Or if you were doing a high fixture, or excuse me, high density work holding, that's also
Mhm.
where the R450s make sense.
Yeah.
But seeing those at oh, what's his name?
IMTS
Henry
or
Holsters.
or Henry holsters. Yeah.
Like those are pretty cool machines. I was pretty sold on those,
Oh yeah, they're
especially
awesome
for
machines.
part loading with a robot.
Yeah. Yeah. No, they're sick machines. I want one in the worst way possible.
That can be your garage machine.
Yeah. Not, yeah. No, I think we're going to be able to get maybe two more machines in that building, and I think one of them is probably going to end up being a Doosan lathe, a Lynx lathe with a bar feeder, and then the other one will probably end up being a Speedio style machine in the center walkway. And
Yeah.
then, unless I can get permission from the state to add on to the building, I'm going to be tapped out on space
You have to
until
get
I can.
permission from the state
Or Benton County, the
for
county
zoning reasons, or like why are they?
zoning reasons. Because they want 70 feet on all sides of the building, and I don't have that, so I'd have to get special permission to add on to the building. So
I'm sorry, I phased out for a second. What? Say that one more time, please.
they want 70 feet from the building to all of the edges of my property line, and I'm already
Oh,
under
okay.
that. And so
Interesting.
I could do it and ask for forgiveness, but I don't really want to do that. I don't think honestly if I did it and like didn't tell them, like I don't think anyone would ever notice
But if you
until
had to
later.
sell the building,
Yeah,
then it becomes an issue, especially because you're growing so fast. Even if you add it on,
that'd only buy me
it's likely that
a little bit of time.
yeah.
So we'll see.
I was looking at commercial real estate for fun today, and there's like a 300,000 square foot facility here in Muncie. If you want to come move in, it's only like I don't know. I remember how much it was. I looked at a bunch of. I think it was like 3 million. It was
It's
a
quite
deal
the
for the amount of size it was.
that's quite the commute.
It is quite the commute. But boy, is property cheap down here.
So you're not gonna get me to say that I want to get rid of the Doosan. I think it's been a good experience, even if it was a bad experience. Like it's been a
Oh,
good lesson.
definitely.
Like I regret having to learn the hard way all of these lessons, but I don't regret learning them.
Yeah. It's like design the everything being a failure. It was a failure, and I spent a lot of time and money on that failure, but I learned stuff from it. Like
Yeah.
it was worth every penny.
Yeah. And if those lessons help me grow the company in a better, more informed manner, then it was worth it. It was an education in what not to do. um and so I don't know. Like the shop that we went and toured, they were a full Haas shop and they were wanting to sell all their Haas machines and go Doosan because they were starting to switch out to Doosan and they really liked it. So like people have different experiences and I don't want to poo-poo Doosan too hard. It's more of, like I said, a level of expectation misalignment than anything.
Yeah.
So, and honestly, if the spindles could handle it a little bit better, or if Doosan had a better way of dealing with me over it, it would have made those lessons a lot less painful.
Yeah,
Um,
I think more than anything, you had a distributor issue.
yeah, yeah,
Because if they had treated that differently, we would have had a much more positive tone.
yeah, yeah.
Speaking of positive tones, no, you're Harrison. Jacob asks, Harrison, you were gearing up to do some ITAR work and mentioned using Fusion. What does that process look like? A lot of people on the internet seem to think it's impossible to use Fusion in an ITAR compliant way.
And the internet is probably right on this one. I took one job,
Ooh,
ITAR, and we did it Fusion offline mode. And I did that purely based on, at the time, hearing of other people doing that. But doing more research on the subject, I would probably agree with the internet in saying that Fusion offline mode is not a compliant method for doing ITAR work. Um,
interesting.
Now, that being said, the the problem is, yes, that Fusion is connected to the cloud. That is part of the problem, but also it has to deal with how you store those files locally. And so, like, to be ICAR compliant, it's a whole system, and Fusion is just one part of that. And I think you could potentially be ITAR compliant with Fusion, but by the slimmest of margins, and you're carrying a high risk factor. And so it would be highly, highly discouraged. Like, I think it potentially could be done. I haven't done enough research on it, and I haven't looked into ITAR work enough to be able to justify it or say one way or another definitively. But I would not recommend it. I will say
It,
that much.
Mastercam is ITAR compliant, right? Because that's all local.
Yeah, and see, I think you can become cloud based and ITAR compliant because I'm pretty sure Onshape is ITAR compliant, and
Yeah,
they're
that does
all
sound
cloud
right.
based.
Yep. They
So
have
I
like a special paid tier for it, but
Yeah. And so it's not necessarily the cloud that's the problem. And so I think Fusion could do it, and they have enough people screaming at them to do it that I don't know if they haven't done it by this point, if they are ever going to do it. And I don't know
yeah.
what the holdup is. Or if Onshape did some sort of deal with the government to get the compliance on their end. I don't know how that all works. Or with
I think I think Onshape just runs in GovCloud or can run in GovCloud
Yeah, maybe that's what it is.
if you pay extra for it. Um, yeah, because it's how the servers and everything is secured, and with Fusion we just don't know.
Yeah.
Um, and if they were, they would advertise it.
Yeah.
So I mean, there's always Inventor with HSM works. It's kind of the forgotten stepchild of Autodesk, where it's not getting a lot of the new stuff, but it is very Fusion like.
I probably wouldn't go down that because that is a path that is dying. And
Yeah,
people are
exactly.
jumping ship from there. And so I would not jump on that ship. I would try to find something looks like it has a future if you're looking
Yeah,
for a system.
which I know Mastercam's always an option. NX, there's what's
Hypermill is Hypermill.
yeah, Hypermill, Power Mill. Power Mill
Um,
also kind of seems like it's getting left behind. Um,
but what's the one that starts with, I think, an E? Um,
Esprit.
Esprit.
I don't know
I don't
anything
know if
about
that
the
one is.
Esprit.
I don't know if that one is or not.
The school might send me to Mastercam training, which would be cool, and give me some Mastercam licenses because they want me to teach that.
Yeah.
Because unfortunately, most of their customers do not use Fusion.
So, to answer that question, I'm not taking on a whole lot of ITAR work. I've taken on one job from Xometry, um, and I did that in offline mode on Fusion, and then I have the file saved locally. But I've been avoiding taking any more just because I'm not informed enough and I don't have anything other than Fusion right now. just to avoid the risk.
I wonder how ITARs and toolpath works. I feel like I asked Justin about this, but I don't remember his answer.
Well, they're so tied
It
to
might have been in the
fusion
someday.
they're so tied to fusion that I don't think like they don't work with anything other than fusion, right?
Not at the moment. I don't know if that's in their roadmap or not.
So if they're only using fusion, then the answer is no, because fusion itself isn't.
Fusion isn't. I know, but even with subtract, we use it for quoting, where our parts may never touch fusion.
Yeah. And the weird thing is, I'm surprised even Xometry is ITAR compliant because I've heard horror stories about them of like I was talking to one of the salesmen that came in and they had dealt with one of the big companies that has parts that are ITAR and can't be found or can't be sourced outside the US, and they would upload parts to Xometry and they were getting stuff from overseas even though they specified US only.
Yeah, say there's
So,
a like when you upload a file to Xometry, it like asks you like, is this ITARs? And you
yeah.
have to check no or whatever, or you just don't check yes, something like that.
Yeah,
Um,
but
on
I think
subtract, we deal with this by saying we do not take ITARs work right now.
yeah, but I think Xometry um at least in the very beginning was sending stuff overseas that was not supposed to get sent overseas. And so
Whoopsies.
at least according to that salesman, and because he was talking about how a lot of the purchasing agents that he dealt with that were sending stuff to Xometry ended up getting let go because of it, and it caused a whole upset. I don't know how long ago that was, but we were just talking about it because he saw that we were Xometry partners, and so it kind of came up.
Yeah. Well, if anybody's looking to source some stuff to U.S. shops, there's subtractmanufacturing.com. Um,
So
which actually, that reminds me, I need to get back to trying to get a cage code, because when I first was in the process of signing up, we had like just become our LLC, and it apparently hadn't percolated through the IRS yet, and so they couldn't verify us. Um, so I need to go back to that, and hopefully they can verify us this time.
yep. We are having to get a lot of stuff set up in our shop to get ready for ISO and all of that stuff. One of the items which I was unaware of and kind of surprised about is an eyewash station. Speaking
Oh,
of
really?
getting certified. Yeah. Eyewash
Huh.
station
Just as like a safety thing.
mhm,
Well,
require an
obviously
eyewash
it's a safety thing.
station. They require all of the exits to be clearly marked, emergency exits,
That makes sense.
eyes and ear protection stations for people visiting the shop. So a lot of OSHA stuff that we just don't really think about when you're a small shop.
Yeah. Marking your fire extinguishers.
Yep, stuff like that.
I I was teaching a class the other day, and we were, there's a OSHA segment, and we were talking about different kinds of fire extinguishers. This was at school. And I got halfway through and I went, do we have fire extinguishers? Where are our fire extinguishers? And so I had to go out into the shop and look around and be like, where are the fire extinguishers? Um, and we did have some. There was like two or three in the shop, and then one in the hallway right outside. It was like, we need better signage on these, because I remember at one point, it was when I was working in an office job, or I was in manufacturing, but in the office, I was doing engineering work. We had a power strip catch on fire just kind of randomly. It wasn't like overloaded or anything. There was just like two things plugged into it, but it decided to catch fire. And I ran off to get a fire extinguisher. And I definitely ran right by the one that was close to get the one that was far away, because I knew where the one that was far away was. And I didn't know where the one that was close was.
Mm-hmm.
And it just brought me back to the shop at school. There's fire extinguishers, but I had no idea where they were. And they're not hidden, but they're not like super publicly viewed. And it's like, I need to put very clear signage on these fire extinguishers, because fire extinguishers don't do you any good if you don't know where they are. And like, if there's a fire, you're generally not thinking super clearly.
I've actually worked a job where I had to go get a fire extinguisher to put out a fire. I've actually had to use one at the job. I was working at an auto shop, and the intake manifold on a car exploded. It was one of those plastic intake manifolds, and it backfired and exploded, and the engine caught fire. And I had to go run and grab a fire extinguisher and put it out. So that was
Yeah.
an exciting day.
We've had 2 different fires in our laser here.
Oh yeah,
One was
but you
me,
didn't
one
have to
was
use an
Scott.
extinguisher on either of them, did you?
So I did on one. Maybe didn't have to. There might have been other routes. On the one that Scott did, I wish he had. And he
Oh
was
really?
like afraid of using the fire extinguisher because it was expensive, and it definitely caused more damage than if he had used it. And so since that moment, there are now fire extinguishers pretty well scattered across my shop in easy to see logical places. But
Now you can get special extinguishers that don't mess up equipment.
you
Do you know what
can.
type you got?
I don't have those. I just have regular ABC ones. But CO2 fire extinguishers aren't that expensive.
Okay.
And CO2 extinguishers are fine on equipment. It's the
Yeah.
powder that's just annoying to clean up. And I've heard it can be like corrosive or something,
Mm-hmm.
but it's a whole lot better than fire.
Yep. Yep. I think that's about everything that I have going on right now. I'm staring down the barrel of a lot of potential work, and I was talking to one of the guys, and I feel like right now I'm playing chicken with an automation solution or another lathe. I'm just waiting for someone to blink, and then I'm gonna have to pull the trigger on one or the other.
Yeah.
Because our lathe is actually becoming one of our busier machines in our shop right now, which has never been the case.
Mm-hmm.
Between
and it's not the
the
most well outfitted lathe in the world.
No, it's a simple 2-axis lathe.
Yeah.
Although I will say that Haas lathe has been holding the tolerances on the medical parts once I got it in the right range really well. It's been pretty rock solid.
Nice.
Now, if you stop and if the temperature starts to fluctuate, it'll get out of that range real quick. But when it's like when it's in the zone and it's just running and pumping out parts, it holds really well. So, one of the guys I talked to wanted to stick heating elements inside the machine to kind of hold that stuff at temperature. Sorry,
Aquarium
I'm
heater
trying
and
to.
the coolant.
Yeah,
I tried to hit the button and it didn't work.
I saw you.
Try again. There we go.
All right, guys.
We've beat this episode with the dead horse.
Yeah, the horse is dead, and we beat it with a sidetrack stick.
Another dead horse.
Another dead horse. Anyways, guys, thanks for hanging out with us, and hopefully this episode caught you up between this week and last week when we were supposed to record and didn't. And yeah, this has been Harrison with Precision Ingenuity signing out with AJ from Subtract Manufacturing. We'll catch you guys later. Taps and patience, our daily grind. In this machine shop, we'll always find joyous struggles, all intertwined. Taps and patience, one of a kind.
Music was very loud today.